Let's look at the graph on the left and let's write a piecewise function for it. So let's think about into how many pieces can we cut the graph on the left. We can cut it into 3 different pieces. This section where the line is increasing, this section where the line is decreasing, and this section where we have a curvature. So let's give each section a different color and let's look at them individually. So now let's write our piecewise function. For the first line is going to be the function in pink, the second line is going to be the function in orange, and the third line is going to be the function in green. Let's start by looking at the function in pink. One thing that we can notice about this section in pink is that it's a straight line, so this function can be defined as y equals mx plus b. And what we need to define in this line, it is the value of the slope and is the value of the y-intercept. To define the slope, let's choose one point in this line, and notice that if I go 1 unit up and 1 unit to the right, I am going to end up in another point in this line. If I did the same movement, 1 unit up and 1 to the right, I'm going to end up in another point in the same line. And remember that the slope is rise over run. Then we can claim that the rise, it is a value of 1, how many units we went up, and run, it is a value of 1, because we're moving 1 unit to the right. Therefore, our slope is 1. Notice that this pink section doesn't intersect the y-axis, but we can use the value of the slope to figure out where we intersect the y-axis. So if I choose this point and I go 1 unit up and 1 unit to the right, I am going to end up in the y-intercept. Then we can claim that the y-intercept is 4. So let's get the value of m equals 1 and plug it into our function. Let's plug in the value of 4 for b, and we should be able to define the function of the pink section. So our function is going to be y equals 1 times x plus 4, which we're going to write down as just x plus 4. So let's plug that in our piecewise function. Now in our function, notice that we are using those x values that are less than -1. And at -1, notice that we do not have an open circle, so we need to put an equal sign underneath the inequality. So we are done with the pink section. Now let's move on to the orange one. So this section in orange, it's another straight line, so we will have the form of y equals mx plus b. Well, let's figure out the value of the slope and the value of the y-intercept. If I choose one point, notice that if I go 1 unit down and 1 unit to the right, we are going to get another point in this line. So here the value of our rise is -1, and the value of our run is +1. Therefore, our slope is just -1. When it comes to the y-intercept, we can see it is part of the graph. It is the value of +2. And now let's plug in the value of m and b in our standard form. We can simplify this as just -x plus 2. So let's plug this equation in our piecewise function. So now let's see what are the x values that this section is using. It is using the values from -1 to 0. But notice that at -1, there is no open circle. So let's put an equal sign underneath the inequality. And notice that at 0, we have a filled circle. So we should also put an equal sign underneath the inequality. So now let's define our last section, the section in green. And the section that we have in green is definitely not a straight line. We seem to be having a parabola. Notice where the vertex of this parabola is located. It is located at the value of 2, 0. Now let's think about how we're going to define the equation of this parabola. Well, one thing I notice is that if I choose an x value that is to the right-hand side of the vertex, the value in my function, it is also 1 higher than the vertex. Let's write down this relationship. If I choose some value of x that is 1 to the right-hand side of the vertex, the y value that I obtained is also 1 value higher from the vertex. And notice that this is symmetrical, because from the vertex, if I choose 1 value to the left, I'm also obtaining 1 value higher from the vertex. So if I choose some value of -1, my y value, it is still 1. But we need more information than that. What if we choose two values that are on the right-hand side of the vertex? What y value are we going to obtain? We seem to be obtaining a y value that is 4 units higher than the vertex. So if I choose some x value of 2, my output, it is 4. And notice that these relationships that we have here, this is the kind of relationships that we observe if we use the value of x squared. So with this information, it is fair to say that this green section that we have here, it is nothing more than the function of x squared, where the vertex is being shifted 2 units to the right. Let's put all this together. Then the equation in green, it is the equation of the parabola of x squared shifted 2 units to the right, which we can write down as x minus 2 raised to the second. So now we have the equation for the third line. So now let's look at the x values that we are using. The section in green starts at the x value of 1. And notice that we have an arrow on the right that is implying that continues without a bound to the right. Therefore, our domain, it is from 1 all the way up to positive infinity, which we can say that we are just using values of x's that are greater than 1. But note that at 1, we have an open circle. There is no need to write down an equal sign underneath the inequality. We have just defined an equation for the piecewise function for the graph that we have on the left. Hello. If you would like to continue learning about mathematics, you can check out the videos on the left.